In this lecture, we're going to go over function and function operations. So we already talked about what the basic definitions of functions are. How do we manipulate them? Well, with these guys, we're going to use some examples. These are your basic function operations. You can add functions together, like so, right here. You can subtract them, which would be something that we do here. You can multiply them and divide them. Those are the relatively straightforward ones. One of the newer ones are going to be composite functions, and that's where you put a function inside of a function. That'll be a little bit more difficult, but we'll go through it. Okay, so for the first one, if we're adding functions, we are just bringing them together. So x squared minus 4x plus 1. We're using our f and g of x as indicated right up here. They gave us our f of x is x squared minus 4x plus 1, our g of x is 3x minus 2. So that's going to be our f plus our g of x, which was 3x minus 2. And you're just going to combine the terms. So the x squared is the only one that's x squared, minus 4x plus 3x would be minus 1x, plus 1 minus 2 would be minus 1. So that's all you got to do for that. Okay, the next one, f minus g of x is going to be x squared minus 4x plus 1, that's your f. And you're going to subtract your g, which is your 3x minus 2. Again, just combine the terms. So x squared is all alone. Minus 4x minus 3x would be minus 7x. And then plus 1 minus negative 2 would be 1 plus 2, which is 3. The next guy, we're just going to do something similar, just multiply them. So x squared minus 4x plus 1 multiplied by 3x minus 2. Don't forget to distribute here, so we're going to do something like this. This to that, and then these two to those, and then this to that. So x squared times 3x is going to be 3x cubed. Might as well do x squared minus 2x, which is going to be minus 2x squared. Minus 4x times that 3x would be minus 12x plus 8x, and the last one will be plus 3x minus 2. Combine all the like terms, we only got one 3x cubed, so that would be 3x cubed. The minus 2x squared, that's, oh wait, I'm sorry, that was my fault. Minus 2x squared minus 12x squared would be minus 14x squared. That would be why that was bizarre. So this cancel. These combine to be 11x. And the last ones combine to become minus 2. Okay, so we're just combining like terms. Let's go down. We still have the function there just so we can see it all right. Let's wait up on that guy. Okay, so next one, f of g of x, or f divided by g of x, the quotient, that's going to be our f, which would be x squared minus 4x plus 1, all over our g of x, which is 3x minus 2. Because these guys don't factor, this is perfectly acceptable. Yeah, no factoring involved, so that's just it. Now let's go to our composite function. So what a composite function means, this little circle, see that little circle right there? Whoops, right there. So what that guy means is I'm going to plug in g of x to my f of x. So I'm going to plug in f of g of x. Well, f just says that anytime I have some number x, I got to square that number, I got to subtract 4 times that number, and then I'm going to add 1. So if we did f of g of x, like this, you would take your g of x and you would square it. Then you would subtract 4 of your g of x's, and you'd add 1. So that's what that means right there. And that seems awfully cluttered, so let's put in our actual g of x. Actually, might make it more cluttered. So f of g of x in total will be our g of x, which is 3x minus 2 squared minus 4 times 3x minus 2 plus 1. Now let's distribute. Don't forget, especially with all these squares, that 3x minus 2 squared is 3x minus 2 times 3x minus 2. So you got to double distribute and give yourself 9x squared. That'd be minus 6x, which would be minus 12x plus 4. This guy is going to be minus 12x plus 8 plus 1. And you're going to bring it again all together. So you'll get 9x squared minus 24x plus 13. That's your full composite function, f of g of x. And I could even ask you g of f of x, and similarly that would be, hey, anytime I have this number g where I plug in an x, I plug in my f instead of the x. I put my f of x. So that would be 3. Oh look, now we get to an x, and instead of plugging in x, I plug in this entire thing. So it becomes x squared minus 4x plus 1, and then I would subtract 2. So that's what this guy would end up being, even though it's not listed as one of your examples. So let's look at functions in terms of the graphs. F plus g of negative 4. Well, that's f of negative 4 plus, I should bring this guy way up to the top so I can draw everything. Oops. Let's move this guy up, move this guy up. Okay. So f of negative 4 plus g of negative 4. Well, we go to our graph. Where's our f graph? Our f graph is this guy right here. This guy that I'm outlining. You see the color, that's enough. So f of 4 is we go to our x value of 4 on the graph, which is right here, and we go up to our f graph, and we see that it's a value of 4. So I'm sorry, that was f of negative 4. So f of negative 4 would be like so, right there. So that's going to be negative 1 plus our g of negative 4. Well, our g of negative 4 looks like he's just at 1. So it would be plus 1, which negative 1 plus 1 would be 0. The next one, f of negative 5, if I go to negative 5 on my f graph, it goes down to about negative 3 minus, so this is going to be f of negative 5 minus g of negative 5. F of negative 5 is negative 3 minus our g of negative 5 looks to be 2. So that's going to be negative 5. That's our answer for that guy. Let's do the next one. F divided by f of 4 divided by g of 4. Well, f at 4, now that we're back to the 4s, not the negative 4, that's going to be 4. And our g of 4 is 3. So that's your answer. He's already simplified as 4/3. G of f of negative 6. Now this means that I got to first go to f at negative 6. Okay, so let's find f at negative 6. You go to f at negative 6, and it looks like he is going all the way down to negative 5. So this means that it's g of negative 5. So first we find this value, we find the function value, then we're going to have to plug it back into the other function. So g at negative 5 we found before was 2. So this whole function, this whole value equals 2. You go to the first function value, you plug it into the other function. So g of f of -2 means that we're going to go to -2 on our graph. We go to our f graph, which is up here. That gives us a value of 3. So that's going to be g of 3. And our g of 3, when we go to that, right there looks to be a value of 2. The last one is f of g of 4. Again, this is another way of writing what we've done. That's the same thing as these D and E. It's just written in a different way. It looks like fog. That's just a little circle. And that will be showing up like that on the test, so be prepared for that. So this is f of g of 4. F of g of 4 is going to be, go to your g of 4. So you go to 4. Your g value at that point is 3. So that's going to be f of 3. And f at 3 is going to be, say 4.7. So that's how we end up doing all of those guys. That's how we do all our operations with functions. And that's how we analyze graphs.